created our groups. Now we can generate a tree. So let's go into Tools and Services and click on it. And then down under Phylogenomics, click on the Bacterial Genome Tree. So we can add up to 100 genomes here. You could add your private genome, or you could add that ANL 2025 genome. So click on that, it pops up, and then you have to click the add box. You need to move it here. And now we have the genome groups that we want to add. So I could migrate to the workspace, I could put the name, or I could do the drop-down box because it's going to show you the groups that you've most recently created. So I'm going to use that and drop that down. And I don't want those yet. What I want are the reference strep and these 90 strep. We're going to submit a couple of trees here. So this, which are the reference, and the 90, which were the close relatives to my genome. Oh, almost 90, 85. 85 is almost, right? Okay, parameters. You could do a quick tree with 10 genes, 20, 50, 100, 500, or 1,000. Trees take a while to build. If you go up to 500 or 1,000, it's going to take a long time and you're going to get frustrated. When would I use 1,000 protein families that the genes are going to use? That would be when they're really closely related. And I've run the tree before and I can see that the bootstrap values aren't good because there isn't enough data to distinguish between them. Even with 1,000, it may not be enough data, but that would be like my last ditch effort to try to trim these genomes, to try to see this relationship. But we'll stick with the default. Now, max allowed deletions or duplications. You can run a service called comparative services before this and see how many global protein families that your selection shares. Now, remember that these have to be one protein per genome in the protein families. Sometimes they have 2 or more copies and sometimes they're missing them. If you have a genome that's really important to you to find out where it is and it's poor quality, you might want to do this. Or if there's a group you're really interested in, you could go up to 10 here. It says 10 of those genomes can be missing this protein family or duplications. They could have duplicate genes of that. So that is an option, but we're not going to need this here. I need a test folder. So let's see, I'm going to click on the folder icon, which goes to my workspace. I'll just click on this and I'm going to create a new folder called Bacterial Genome Tree. Create that folder. It pops up. I click on it and I say, okay, so the folder's there. Now I have to tell what this is. Reference public ANL 2025 strep genomes. There. All right, now I could submit this right now. Let me turn you on to something that's really awesome about this service and really wonderful about the trees. So let's click on metadata options. And these are things you can use to color the existing tree. Now the genome group is going to be in there already, but you want the genome name and the genome ID. Strain, if it's bacteria, I'm not that interested in it. Host, isolation country, host common name, collection year. Yeah, those are okay, but I might want geographic group. And when I click on that and add it over, and you can go into more options, like I might want the serovar and see if I can see patterns in the tree with those. So we have everything filled out. Let's submit this tree. And it says it's been successfully submitted. All right. Now, while we're here with everything exactly the same, I want to go in and submit the tree with the tetracycline resistance and susceptibility genomes. So I'm going to remove the almost 90, and I'm going to remove the reference. And then I'm going to click on this again. I'm torn because I really like a tree when it's well rooted. You'll see it gives you a feeling of deep satisfaction in your soul, but we can be a little less satisfied in our soul just to demonstrate something. So susceptible, add the resistant, add. Did I add it? Yes. Yes. There we go. And I want to keep that guy in because he's my private one. And remember, it's tetracycline susceptible. So we'll see how that pans out. All right. We need a name for this. Tetracycline sus-res comparison tree. Is that good? You think that one's okay? All right. We go down. I want the same metadata here, and we're off. Well, we're not off yet. We're not off until we see this, and it has been successfully submitted. So in the next lesson, we'll look at results. I know, it's exciting, isn't it? I shall see you in the next video.